Hi my dear friends, welcome to this video. In this video I am going to discuss the topic solutions of partial differential equations. Solutions of partial differential equations. Already we came to know that the partial differential equation is z be the function of x and y, that is the concept. So my ultimate aim is to find out the z value. Now I can divide the solution by its order. Suppose it is first order partial differential equation. What are the first order partial derivatives? Dou z by dou x, that is small p, dou z by dou y, that is small q. Suppose if it is a second or higher order partial differential equation, then the complete solution of the second or higher order partial differential equations is consists of two parts. Is a combination of, it's a sum of complementary function and particular integral. For second order, the complete solution is the sum of complementary function and particular integral. Got it? Now let us back to the first order partial differential equation. The first order partial differential equation is suppose given, then the solutions can be categorized by four types. One is complete integral, second one is singular, second one is a particular, third one is singular, fourth one is general. Let us see what is the first type. What is the first type of integral? That is a complete integral. Suppose let phi of x comma y comma z comma a comma b equal to 0. Phi of x comma y comma z comma a comma b equal to 0 be a solution of the given first order PDE f of x comma y comma z p comma q equal to 0. What's the p and q? First order partial derivatives. So suppose let us assume that this is the solution. This is the solution of this partial differential equation. Let us count the number of arbitrary constants. How many are there? 2. So how many independent variables? X and y 2. So they are in equal number. If there are equal number of arbitrary constants and the independent variables, while elimination of the arbitrary constant we get the first order PD. The same idea here. In the solution, suppose there are equal number of arbitrary constants and the independent variables, then that is called the complete integral. It is called the complete integral CI. Once we found the complete integral, let us proceed further with the help of the complete integral. So in the complete integral, there are some arbitrary constants a and b. If we assign different values or particular values to the constants a and b, then we may name this, that is particular integral. That is the second one. And the third one, how many arbitrary constants are there in the complete integral? 2. Differentiate partially with respect to those two constants, namely a and b, and equating it to 0, we get the two equations. That is dou phi by dou a equal to 0, dou phi by dou b equal to 0. So this is equation number 2 and 3. Now eliminating both the arbitrary constants a and b from number 2 and 3, if it is exists, we get the required singular integral. Got it? And the last one, the fourth one is general. This also we can derive from the complete integral, that is equation number 1. In equation number 1, there are two arbitrary constants. Let us assume that, or let us take any one constant be the function of the other one. So let us consider b is a function of a. In the complete integral 1, we get is a phi of x comma y comma z a comma, what is a b now? Is a function of a equal to 0. So this is my equation number 4. So how many constants are there? Still we have one more constant a. Now differentiate this 4 with respect to a. With respect to a and equating to 0, we get dou phi by, not dou d phi, because only one constant. So d phi by dA equal to 0. This is my equation number 5. From 4 and 5, eliminate that constant a. If it exists, then that solution is free from the arbitrary constant, that is called the general integral. So anyhow, our ultimate aim is to eliminate the arbitrary constants, that is the ultimate aim. In the first one, the first category, complete integral, let us count the number of arbitrary constants. They are an equal number, it is called complete. When we assign particular values to the constant, it is called the particular integral. Differentiate both the constants and equating to 0, eliminate those two constants from these two equations 2 and 3, then we will get the singular integral. Assume that b is a function of a or maybe a is a function of b, and we differentiate that two with respect to the a or b, eliminate, we get the general integral. So that is the different types of integrals of first order partial differential equations. Thank you.